Have you ever wondered how an AI seems to know exactly what to say next? It's not actually magic or mind reading. It all starts with a simple game of fill in the blanks that we play every day in our own heads. When I say once upon a, you immediately think time. This simple act of predicting what comes next is the foundation of how large language models, or LLMs, work. At its simplest, an LLM is a system designed to predict the next piece of text in a sequence. It is the brain or the cognitive engine that powers modern AI assistants. To an AI, text isn't made of words, it's made of tokens. A token can be a whole word, a part of a word, or even just a comma. Think of tokens as the individual puzzle pieces the AI uses to build a sentence. Everything an AI does, from writing a poem to coding a website, emerges from this one foundational act, choosing the next token that best fits the pattern. It does this over and over, one piece at a time, until the job is done. How does it know which piece fits? By reading almost everything humans have ever written. It studies books, scientific papers, and conversations to learn the patterns of how we communicate. Before LLMs, we had to build a separate AI for every single task. Now, by teaching a model the general structure of language, one single system can suddenly do everything from translating French to writing Python code. When we call these models large, we aren't kidding. We're talking about parameters, the billions of internal values the model adjusts during training to store the patterns it has learned. Each parameter represents a tiny piece of a pattern. Earlier models were too small to understand logic. They could mimic style but couldn't really reason or solve new problems. A strange thing happened as these models got bigger. They started solving problems they were never specifically programmed to handle. This ability to reason and follow complex instructions emerged naturally from the sheer scale of the data. Most modern LLMs use an architecture called a transformer. Its secret weapon is self-attention, which lets the model look at an entire sentence at once to understand how words relate to each other, even if they are far apart. The transformer allows the model to attend to the most relevant parts of your prompt. If you're talking about a bank, the model looks at nearby words to decide if you mean a river bank or a financial bank. The first stage of life for an LLM is pre-training. Here, it simply learns to continue text from a massive corpus of data, absorbing grammar and facts along the way. A pre-trained model is just a text completer. To make it a helpful assistant, we use instruction fine-tuning. We give it thousands of examples of how to follow commands and format helpful replies. Finally, we align the model with human values using feedback. This ensures the model's predictions aren't just accurate, but also safe, polite, and actually what a human would want to hear. Every time an LLM predicts a token, it's actually doing math. It calculates the conditional probability, the likelihood of a word appearing given all the words that came before it. Once the model calculates the scores for every possible word in its vocabulary, it has to pick one. The most common way is simply to pick the one with the highest probability. Here's the catch. If the AI always picks the most likely word, it becomes repetitive and boring. To make the AI feel more human and creative, we have to introduce a little bit of controlled randomness. We control this randomness with a setting called temperature. A low temperature makes the model safe and literal, perfect for facts. A higher temperature lets it take risks, making it great for writing stories or brainstorming. Another tool is TopP, or Nucleus sampling. Instead of looking at every word in existence, the model only considers a small pool of the most likely words that add up to a certain percentage of the probability. There is a new rule in AI. Models get smarter if you give them more thinking time. By allowing the model to generate multiple paths and check its own work before answering, its accuracy on hard problems skyrockets. Sometimes we don't just want the answer, we want the logic. By prompting the model to think step by step, we force it to show its work, which makes it much less likely to make a silly mistake. There are different ways to navigate the probability tree. Beam search explores multiple possible sentences at once to find the best overall sequence, while contrastive search ensures the output stays diverse and avoids repetitive loops. Remember, an LLM only knows what it learned in school. Training. If you ask about today's news or your private files, it will have no idea because that data wasn't in its original training corpus. This is where RAG comes in. Instead of guessing, the model looks up the answer in a database of your documents, adds that info to the prompt, and then summarizes it for you. We are moving from AI that just chats to agents that act. By predicting the right tool call instead of just the next word, an LLM can now browse the web, send emails, or even fix code. As AI gets more powerful, safety is critical. We use guardrails and the principle of least privilege to ensure an agent only has the exact permissions it needs to do its job, preventing it from accessing sensitive data by mistake. If you want your AI to work reliably with other software, ask it for JSON. Structured output removes the guesswork and makes it easy for other programs to understand the AI's thoughts. Think of a basic LLM like a paper map. It shows you the world as it was when printed. An AI agent is like a live GPS. It uses next token prediction to constantly recalculate its path based on the traffic of new information it receives. Your results depend on your prompt. Use active verbs like analyze and summarize or extract to tell the AI exactly what operation to perform on your data. Remember the temperature lever. Set it to 0 for logic and facts to avoid hallucinations, and turn it up when you want the AI to surprise you with creative ideas. If the task is hard, don't just ask for the answer. Ask the model to think step by step or provide a reasoning trace to ensure it follows a logical path to the finish line. To wrap up, LLMs are powerful pattern matchers. They break the world into tokens, use math to predict the next piece, and use scale and architecture to turn those guesses into intelligence. We've only scratched the surface. As we learn to better orchestrate these predictions, we are building a future of autonomous partners that don't just talk, but truly help us solve the world's complex problems. The canvas is in your hands and the patterns are yours to use. It's time to stop just using AI and start engineering the future. Thank you for watching.